All right, we're going to go over Postclass assignment 7D number 4. Remember, as always, that you might have different numbers than this, but this will hopefully help you understand how to solve it. Okay, so we've got an object with mass of 54 kilograms fired from the top of a cliff. So let's draw our cliff first. We got our cliff first. It's 116 meters high. Here's our mass, 54 kilograms. Angle is 30 degrees above the horizontal, and it has a V naught of 1.22 times 10 to the 2 meters per second. So part A asks us to determine the total mechanical energy. So our total initial energy is our kinetic energy plus our potential energy, which is 1/2 mv squared plus mgh. So 1/2 times 54 kilograms times 122 meters per second squared plus 54 kilograms. Scooch this over. Times 9.8 meters per second squared times 116 meters. And that gives us a total mechanical energy of 4.63 times 10 to the 5th joules. Okay, so then the next part of the question says when it's at its maximum height. So imagine that we've got this projectile that could going here. It's at its maximum height, which is 271 meters. Drawing here is very much not to scale. It's now traveling at 86.5 meters per second. We want to determine the amount of work that has been done on the projectile by air resistance. Okay, so here our energy at the maximum height is our kinetic energy plus our potential energy, which is 1/2 mv squared plus mgh. So at this point, our mass is still 54 kilograms. Our velocity now is 86.5 meters per second. And then our gravitational potential energy is 54 kilograms. Times 9.8 meters per second squared times our height of 271 meters. And those give us a total energy at this stage of plugging in the numbers. That gives us 3.45 times 10 to the 5th joules. And so then our energy initial minus our energy at the max height is the work. Oh, I shouldn't have had a negative sign there. The work non-conserved. No, sorry, that negative sign was right. As the negative of the non-work. In other words, our delta E, which is our E final, E max minus E initial, is our work non-conserved. So when we plug in the number from up here as well as this here and take the difference, we get that our non-conserved work is negative 1.18 times 10 to the 5th joules. Okay. And then the last question, C, is what is the speed if air resistance does 1.5 times as much work on the projectile when it is going down as it did when it was going up? Okay. So now we're going to think about this initial moment as the top of its arc. Okay, and we know that its energy at that moment is 3.45 times 10 to the 5th joules. And we know that our work non-conserved on the way down is negative 1.5 times non-conserved on the way up, which is not negative there, 1.5 times that. All right, which is 1.5 times 1.18 times 10 to the 5th joules. And E final minus E initial is that work non-conserved going down. Our E final is just 1/2 mv squared because our final height is 0. Okay, so we've got 1/2 mv squared equals E initial plus work non-conserved on the way down. So V squared is 2 times 3.45 times 10 to the 5th joules plus we have 1.5 times 1.18 times 10 to the 5th joules over our mass, which is 54 kilograms. So then our velocity is take the square root of all that, which gives us a speed of 79 meters per second. All right. Have a good night. Thanks.